So boys and girls, in this video we continue our tutorial discussions. Okay, so we recap. In the last tutorial sessions we discussed about the Faraday Law. So through the Faraday Law we can calculate how large is the EMF induced due to the change of flux over time. So since flux is BA cos theta, so we find out that the change of flux might come from the change in B. So when there is a changing in B, so the EMF induced is negative NA dB over dt. And also we have the second ways in order to induce EMF, whereby we change the area. We change the area with time. So we find out that as the area change, the flux change. So it will induce EMF. For these equations, we can calculate the EMF induced by using equation negative NB dA over dt. So in this tutorial, we are going to continue with the third way we can induce EMF. Okay, so the third way we can induce EMF is by rotating the coil in magnetic field. Boys and girls, basically, when we have a coin, for example, we have a coin, I draw the side view of N turns. We have a coin of N turns. When we put it in magnetic field of field strength B, and then we rotate the coin. So we will find out that actually the flux will change. The flux will change with time when we rotate the coil. How come the flux will change with time when we rotate the coil? This is because the value of flux actually depends on the angle between the B and vector A. So as we rotate the coil, the value of angle theta change. So it will bring the change to the value of flux. Okay, I show you in the videos. Observe what happened to the value of flux as we rotate the coil in magnetic field. See, the value of flux will decrease when we rotate the coil. I repeat. Why? This is because we find out that as we rotate the coil, the angle between the normal vector A and the magnetic field changed. Okay? So when we rotate the coil, there will be a change in magnetic flux. So when there is a change in magnetic flux, means that there will be EMF induced. So how we find the EMF induced for the rotating coil? So we can refer to our Faraday Law. EMF induced is negative N d flux over dt. As the flux change, we are going to induce EMF. So we know that flux is BA cos theta. And from the video just now, you can see obviously our angle change with time when the coil rotates in magnetic field. But our B and area of the coil is still remain the same. So we take out the B and A. So the physical quantities that change with time is the angle between vector A and B. So this angle can relate with how fast we rotate the coil in magnetic field. Whereby if you recall your prior knowledge in rotational motion, omega, angular velocity, is the theta over time. So we put it in negative NDA d over dt cos omega t. So we differentiate the equations. We differentiate the equation. So negative NDA. Differentiate cos, we get negative sine omega t. Differentiate omega t, we get omega. So finally, we get the equations to determine the EMF induced when coil rotates in magnetic field. The EMF induced will be NBA omega sine omega t. So this is the equation we use to determine the EMF induced when the coil rotates in magnetic field. Okay, let us see one question in our tutorial. Question 3. A circular coil of radius 3 cm is placed inside a uniform magnetic field of 0.2 Tesla. Wait, its plane is at an angle theta with the direction of magnetic field. Okay, so A, determine the magnetic flux through the coil when the angle is 60 degrees. So the question A asks us to find the magnetic flux passing through the coil when the angle is 60 degrees. This angle 60 degrees is referred to the angle between the plane of the coil with the directions of magnetic field. So we try to visualize the questions. So this is your circular coil. Let's say this is our circular coil. So this is the circular coil, our circular coil. So the magnetic field is directed 60 degrees with the plane of the coil. So let's say this is our magnetic field that passing through the coil. So the angle between the magnetic field line with the plane of the coil is 60 degrees. So we want to find what is the magnetic flux that passing through the coil. So the equation to calculate the flux is BA cos theta. But we have to bear in mind, if you recall what we discussed in previous tutorial lesson, the theta is referred to the angle between vector A and B, vector A and B. So in these equations, the angle shouldn't be 60 degrees, okay? So this 60 degrees is the angle between the area, the plane of the coil with B. So this is not the value that we should substitute in order to calculate the flux. So we draw our vector A. So perpendicular to the surface area or the plane is our vector A. So we can see obviously this one is the angle theta. So our theta should be 90 minus 60 equal to 30 degrees. So we put it in here. Our B is 0.2. The area can be calculated from the radius. So this is a circular coil. So our area will be pi r squared. So we have pi multiplied with the radius 3 centimeter, change it to meter, cos 30. So you might pause the video to do the calculations. So if you calculate correctly, you should get the value of the flux is 4.897 to the power of -4 Weber. Now we're done with question A. We proceed to question B. So if the coil is now rotated through about an axis through its center and perpendicular to the field at a rate of 4 rotations per second. So how fast is rotate? So given the angular velocity, the coil rotate in the magnetic field is 4 revolutions per second. Rotation means revolution, berapa pusingan. So in within 1 second, it have 4 rotations. So what is the maximum EMF induced in the coil? So we want to find the maximum EMF induced in the coil. So class, we understood that. For this question, we are going to induce EMF as the coil rotates in magnetic field. So the equation to calculate the EMF induced for the situation of rotating coil in magnetic field is given by EMF induced equal to NBA omega sine omega t. So we want to find the maximum EMF. So we understood in mathematics, the maximum value for sine omega t will be 1. So when the value of sine omega t equal to 1, then our EMF will be maximum. The value of EMF obtained will be maximum. Okay, so the EMF maximum that we want to calculate for sure will occur when our value of sine omega t equal to 1. So if this one equal to 1, so we only left with NBA omega. Then we put in, substitute all the value given in the question. So if we refer back to the questions, so a circular coil, so the numbers of turn is 1. The magnetic field strain is 0.2. The area is pi r squared. So, okay, then the omega. So class, the omega given in the question is 4 rotation per second. But then class, you have to remember 4 rotation per second, RPS is not SI unit for angular velocity. So we have to change it to radian per second. So I do the unit conversion here. So we have to do unit conversion for omega. So omega is 4 revolution per 1 second. Rotation means revolution, berapa pusingan. So we have to change it to radian per second. So we understood complete 1 revolution is equivalent to 2 pi. So we have 4 times 2 pi over 1 second. Second is SI unit. No need to do unit conversion. So we are going to have 8 pi radian per second. So after we have do the unit conversion for angular velocity omega, then only we put it here. So we have 8 pi. Then you might pause the video to calculate the maximum EMF generated as the coil rotates. So if you do your calculation correctly, you should get 1.42 to the power of -2 volt. So you might try another question that have the similar concept. So you might try question 6 in your tutorial 5, in which that question also is about rotating coil.